Hello everyone, this video has been brought to you by an academy. My name is Mohit Gupta and in this video I will be talking about what are deterministic finite automata, popularly known as DFA. So before going into DFAs, let us see what an automata is. An automata is a machine that takes as input set of coded instructions and outputs a range of predetermined responses according to different circumstances. So it is a machine that takes input set of coded instructions and outputs a range of predetermined responses according to different circumstances. That is an automata in simple words. So let us see an example of automata. The simplest example is a finite state machine. So what is a finite state machine? It has finite number of states. For example, take this figure. This is an on-off switch for a bulb. When the switch is turned up, the bulb starts glowing. When the switch is turned down, the bulb stops glowing. So this is an example of a finite state machine and the simplest automata possible. So now, what is a deterministic finite automata? A deterministic finite automata is a machine that has for each state and for each of its input symbols exactly one output stage. That is a DFA in simple words. So let us try some example to understand what an DFA actually is, and this definition will become clearer then. So this is a regular expression given to us: A or B, 0 or more occurrences. To construct the DFA for this given regular expression, we have a start state that leads to a state 1. Now we have two input alphabets. It can be A or it can be B. So we can reach states 2 and 3. It might happen that A keeps on repeating. For example, if the input is something like this, then A keeps on repeating and the machine will remain at state 2. And it might happen that the input B keeps on repeating in the case of this type of input. So the machine will remain at state B, that is 3. So if an input of this type occurs, then the machine will go from 1 to state 2 and then from state 2 to state 3. If an input of type this BA occurs, then the machine will go from 1 to 3 to 2, and this cycle keeps on going for any number of string inputs. Since we have no further state, and this state and this state, including this state, will be called as accepting states. An accepting state is the final state possible of an DFA. So why is 1 an accepting state? Because we have 0 or more occurrences. If the string is an empty string epsilon, then the machine will remain at state 1 and that will be its completion state. So 1 is also an accepting state. 3 will be an accepting state for all the strings ending in B. 2 will be accepting states for all the strings ending in A. Let us see one more example. In this example we have A 0 or more occurrences, or B 0 or more occurrences, whole 0 or more occurrences. So let us start making the DFA for this. As usual, we have start state going to state 1. We have two possible inputs, A and B, and we reach state 2 and 3 respectively. Now, what are the possible inputs? We definitely have an empty state, so this one becomes an accepting state. Empty string input, upon empty string input, 1 will become an accepting state. We can have strings like A n number of times, and B similarly n number of times. So as we had seen in the previous example, 2 and 3 are also accepting states. Suppose we have a string like A and it ends in B, then this automata will move from 2 to 3. Similarly, if we have an input like B and ends in A, then this automata will move from 3 to 2. So this is what our DFA for this regular expression look like. Let us take one more example. In this example we have got at least one AB. All the strings in this regular expression will start from AB. So we begin with start, we go to state 1, we have input A, we go to state 2, we have input B, we go to state 3. Now the possible inputs are again A and B, and we can reach states 4 and 5. It might happen that there are no further inputs except for AB, so this is an accepting state. It might happen that an input is of the format of repetitive A's after AB, so this is an accepting state. It might also happen that it is a string of repetitive B's after AB, so this is also a accepting state. And similarly, on input A and input B, the states will change like this. Also, it might happen that in the starting we can get an input like BA. So we do not have any state to start off with, so it will keep on repeating the state 1, that is the start state. Also, if after one single A we get another A input, it will go back to the initial state. So this is the required DFA for this regular expression. Subscribe to our channel www.youtube.com/unacademy to watch all the latest videos. The upcoming videos in this series are NFA and NFA to DFA conversion. If you have any doubts or queries, you can ask me on Twitter. My Twitter handle is hi_Mohit Gupta, or you can leave a comment in the comment section of this video. Thank you. Keep watching.